Okay, good morning, folks. Thanks for joining us this morning for the Introduction to Fusion 360 webinar. We've got quite a lot of content to go through today, so we'll crack on. Let's just have a look, make sure everyone's in. If people could just give me a thumbs up or just in the chat column to say that you can hear me okay, that'd be great, just to give me feedback that everything's working okay for yourselves. So, yeah, great. So I've got some feedback there. Thanks very much for that. So we'll move on. So today, or this morning, what we're going to cover is just a brief introduction around what Fusion 360 is. We've also got a collaborator on the webinar today. We've got Johan from Sandflow Golf Co, who's going to talk a little bit about what he's using Fusion 360 for and what those guys do based over there in Sweden, which is good. And then we'll get into a technical demonstration with Fusion 360 itself. And that'll be a brief overview, really touching on most of the areas that are within the software to give some idea of capability and what you can do with it. So to start, before we get into any product really, I want to talk a little bit about what we're looking at Autodesk here and how we're approaching things, if you like, with something that we're calling our product innovation platform. Now, that product innovation platform is part of a story that we're telling called The Future of Making Things. And that relates to how we see manufacturing and the whole design make use scenario moving forward over the next few years. Our solution to that is this product innovation platform, where we're talking about being able to offer a platform that integrates between different areas of design, make, use, and looking around that diagram there, things like generative design, industrial additive, and then connected products for Industry 4.0, things like that, and how we approach that really as a company. Fusion 360 is one of the products at the heart of that, and today we're going to focus on that design environment with Fusion. So really, to start, an integrated product development platform. Basically what that means is one platform to go through different stages or different tasks within side of manufacturing and production and engineering. So if we look here, form, function and fabricate, so going through concepts, engineering and production rather, being able to have the tools inside of one box, if you like, to enable that to happen, rather than being segmented and going out to different products. I'm sure most of you are aware of social media. I've not come across anybody who isn't these days, but if you just go and do a quick search out on the web, be it Twitter, Facebook, any of the normal ones, Instagram, the three that we've got listed here, Autodesk Fusion 360, you'll see there's an awful lot of activity and some fantastic stories being told about what people out in the workplace are using the product for, and also developments as time moves on, which I'll come back and touch on a little bit later on. It's not just about sort of the woolly stuff, if you like, with social media and just communicating a good story. We're seeing Fusion 360 being utilised very successfully in all of these four areas, really. So maker spaces, because it's available to people as hobbyists or startups, at low or free cost in certain instances, then we're seeing a large uptake within those spaces, and also the idea that it's a fresh approach to 3D CAD or a design process really, that's allowing that to be taken up within those spaces quite quickly. Startups, as you say, companies that have got an idea and moving forward, want a tool to be able to do multiple tasks to get a product manufactured and designed very quickly and easily. We're seeing a lot of uptake in that area as well. We're also seeing industry leaders out in the marketplace. So the big companies are starting to take note of this and starting to utilise some of the features and functionality we've got with inside of Fusion 360 to allow them to start looking at what the future is, or as we see it for sure. We're also seeing it as a disruptor. So from our perspective, it's really starting to be seen as a game changer. It's a fresh approach to 3D CAD, which hopefully you'll see as we move through, and hopefully Johan can actually add some substance to that. So Fusion 360 itself, where did it come from? What is it? Or not so much what is it, but why is it there? And one of the main reasons is we actually went out in the marketplace and started to ask people what designers and engineers, those people, what they actually want. What are they looking for? What are the things they have problems with right now? What do they find not particularly good, or what do they have niggles with? And there were three key areas really. The first one being able to access the information anywhere. So this is device independence, i.e. whether it's on a Mac, whether it's on a PC, a mobile device, being able to get at that data and do something with it. So that was one of the key areas. And then being able to work collaboratively, and this is something I see time and time again when I'm out in industry talking to companies right now about whatever product it be. The world's a much smaller place, and we're seeing that people want to start collaborating much more intelligently. So that was another key area that's prominent today. And it's kind of, well, those two areas, there's a little bit more that we'll cover later, but those two areas are really where Fusion 360 came from. So it's allowing us to have an integrated platform, i.e. it's not just about 3D CAD or design, it's about being able to do other things in there as well. Being able to connect things together, so have that collaborative environment, and making it accessible. So it doesn't matter whether you're using a PC or Mac, for example, we can go either way. Okay, so that's really where things have come from. So at this point, I'm going to hand over to Johan, and just if I can find him on my, I'm going to hand over to Johan and just let him talk a little bit about what Sandflow are doing, or what they are as a company first of all, and then a little bit more insight into the product that they've got there. Are you there, Johan?
Yes, Dave. Thank you. Can everybody hear me? Okay.
I can hear you at this end, so I'm presuming everyone can hear on the webinar. Okay.
Okay. Super. Well, thank you, Dave. Yeah, as Dave mentioned, Sandflow Golf is a high-end custom putter maker. We make putters we have customers nearly all over the world. We have customers in Australia, America. I think we have customers in Japan and in Europe as well. Well, a little bit of a history about me. My background is aerospace engineering. I started my career in an aerospace company here in Trollhättan, Sweden, as a CNC programmer and machinist, and eventually started my own machine shop. So I have actually two companies, a machine shop that does like contract work for bigger companies, and the putter company that we make high-end putters.
Perfect.
Oh well, yeah, that's a little bit about me.
Okay, so I guess there's some images there from what you're actually doing. Some of the images that you sent over, Johan. So yeah, high-end putters. Have I got that right?
Yeah.
Yeah.
And a high level of customization. We never make two of the same.
Okay.
Every putter is unique.
Yeah. I particularly like the like little putting range you've got in the shop there.
Yeah, product testing. Yeah.
Product testing, absolutely. Great stuff. Great stuff. I mean, from some of the information you sent across to me that we'll look at later, and having a brief chat to you as well, it's really interesting what you've been doing with how you've got into this really. And I guess from my point of view, we just move on to the next slide. Sort of understanding really how Fusion 360 has helped you with different number of requirements or tasks from a concept design to right through to manufacture, and how that's helped you get to where you are really.
Oh yeah, since Fusion is a complete package, everything is in one solution. It makes it real easy to, as you can see on the picture there, like start from a sketch that I have in my head, just start sketching on a paper, and then you can import that to Fusion and start modeling on that, like kind of like idea that you have. And yeah, as I said, since everything is in one package, it makes everything so much easier to start. You have your idea, and then to a finished product. The whole process, the whole workflow is super easy compared to if you have different software for one each thing.
Yeah, perfect. Okay. Thank you. Well, I mean, one of the other things we discussed, and I'll have to make an apology here, Johan, because the picture on the left is something I just, you may have noticed I modified your club just to highlight.
No worries, no worries. That's a future model, yeah.
Yeah, great. So yeah, I mean that's another area that we talked about, the challenges that you face today in a 24/7 design environment, and how you go about that really.
Yeah, since Fusion is cloud-based, it really helps me when I can access the files from anywhere. If I start a design at work, and I'm a family man, I have kids, I need to somewhat have scheduled times when I get the kids and all that. But the super good thing with Fusion and the cloud-based is that when the kids are asleep and I have some time over, I can start working on the designs, on the CAM, on the simulation, or whatever I did at the shop. I can just start Fusion up on my computer at home and just get to work immediately, just where I left off. Yeah. So and that helped me a lot. And since all the files were stored in the cloud, you always work on the latest.
Yeah.
There's no need to change files between different programs and lose data and format to different file types. Everything is stored nice and safe, just to continue working really.
It's a really good point, that, Johan, because it's something I've realised myself, having started to use Fusion a while ago now, just how convenient it is to do something quickly, put it down, it's saved back to the cloud, and then you can come back to it from either the same machine or another machine, just log in and carry on where you live, really, which is great.
Yeah, because I used different softwares in the past, and you don't get that ease of use and that mobility with the standard software. When it's cloud-based, you can access it from anywhere. For example, when I make a mock-up of a putter, as I said, nearly no putters are the same. There's always different customization, engravings and such. I can make a mock-up, send a link to my customer. He can click on the link, and it pops up a fully rotatable 3D model in his web browser. for him to spin around, and it makes the design process and the visualization so much easier to get the point across. And you can also in my as a machine shop, you can bring kind of like a design or a mock-up to my customer on my phone, and I open Fusion on my phone or my iPad and show them to. I don't have to bring my computer. They don't have to come to me. So the Fusion of the cloud is awesome in every way.
Fantastic. Thank you. Okay. So I guess moving on to one of the, particularly for me, one of the interesting areas, because I served my time as a machinist many years ago on the shop floor before this level of complexity was available. But I still like seeing machines operate, which is a bit strange, maybe. There we go. So yeah, I mean, coming back to that point that you made of everything being in one package. So yeah, how did that help?
Well, it helped very much, really, because you don't lose data, and since I've used loads of CAM software and CAD software in the past, and if you use say a quite modern CAM software, there's always, they have CAD in their software, but it's not that good. It's kind of like forced to, so they can call it the CAD CAM software. But in Fusion, you have super good CAD and super good CAM. Because CAM was the main thing that got me hooked on Fusion. That was the first thing that I tried, really, when I came across it in like 2014, I think it was.
Yeah.
The tool paths and the strategies are second to none. They are real awesome. They're modern. They have the dynamic milling is the kind of like the industry name for it. Here it's called adaptive clearing.
Yeah.
And it's super good. Super good.
Perfect. Okay. It's again, from my perspective, it's one of the things that I've found quite easy to get on with. First of all, that it's embedded inside of the product, but secondly, it's easy to use to start doing something, which obviously is the feedback you've just given, but it's feedback we get from other customers as well. So it's
yeah, the ease of use, and some CAD and CAM software could be real hard to learn. You don't understand anything what's the screen and the options you can choose, but here in Fusion everything is straightforward, and you get the tool tips. If you don't really know what anything means, you just hover the mouse over it and it explains it to you. Yeah. So it's I think it took me like 30 minutes the first time I used it to make a quite advanced machining strategy.
Yeah.
So it's really easy to use.
Excellent. It's interesting from my perspective as well, because I've been to a few of the local maker spaces in and around where I live in Manchester in the UK, and sort of there was quite a bit of interest in Fusion, what it was and how you'd go about modelling. But one of the key things was people were asking about the CAM side of things for all manner of sort of reasons. But it was one of the things that stood out very early on from having initial discussions, not so much with the people that ran the maker spaces, but users that were actually there. They'd heard a little bit and they wanted to know a lot more. And CAM was a big area that they were interested in having a look at. So it was really interesting. Good. Okay.
Yeah, as I said, the CAM side is phenomenal. I use it every day.
Yeah. Perfect. Thank you. Well, that's great. And thank you very much for sort of talking a little bit about what you've been doing, Johan, with the products. If you're okay to stay online, and maybe if there's any questions at the end of the webinar, if
Yeah,
we can have a chat around those, that'd be great if you could.
sure.
So perfect. So let's just move on a little bit, if I get my PowerPoint working. So Fusion 360 itself then, let's talk a little bit more about what it is rather than where it came from. And if we look at sort of what's in the box, and this is changing on not a daily basis, but certainly a weekly basis to a certain degree. 3D modeling, as you'd expect, we have a full capability to produce parts and assemblies inside of Fusion 360. Produce 2D drawings of those parts and assemblies is in there as well, as you'd expect. But this is a key area, and it's again something that I'm starting to see a trend out in the marketplace where people are using 3D design tools and 3D modeling, but the reliance upon those 2D drawings is not becoming less, but you see in certain areas start to move away from it because they're going directly to CNC machining and using the CAM tools that are inside of here already. The reliance or the requirement even for the 2D drawing is starting to fade away in certain areas. Really, it's a communication tool at the end of the day. But because we can go directly from 3D modeling into CAM and then straight out to a machine tool, we're able to review that 3D model, interrogate it, and understand what the 3D model's actually descripting from the 3D model itself. That 2D drawing is becoming less of an important part, is what I'm seeing in industry at the moment. Moving on, really touching on that same point, is project collaboration. So this can be internal to the company or it could be external to the company. It's a way of collaborating the data that you've got with inside of Fusion, be it design data, additional information, whatever that be, is all open and available to collaborate with. I'll show you a little bit of that when we get into the demo. Simulation. Again, we said it's a platform. It's a collection of tools. So we have some quite good simulation tools in there that I'll talk about a little bit during the demo. And as Johan's quite rightly said and talked us through, a CAM module as well. Well, not a module; it's part of the package. It's a tool in the box to allow you to do computer-aided manufacture. Not only that, we also have a 3D print facility in there as well. So for sending out to 3D printing, and that's a really big area at the moment. Traditionally, we think of 3D printing as plastics. It's not the case these days. There's an awful lot of industrial additive being done, and not just now. It's been happening for some time, but it's becoming more and more prevalent within industry now. Only yesterday I was looking at something to do with a jet engine that was actually had 3D printed components inside of it. And then probably my favourite area of Fusion to round off is rendering. I'm a keen photographer in my spare time and produce a lot of, or create images, shall we say. And the rendering within Fusion 360 is, if we balance ease of use against what you can get from it, it's by far and away the easiest product I've come across for quite some time. Really is a really nice tool set in there. There's a lot more in the product than just those areas, but those are the sort of the headline areas, if you like. One other area that's not listed on there, thinking about it, is being able to do like exploded animations of an assembly. So sort of Haynes manual type thing for those of you based in the UK. So what all that sums up to really is, for me it's a fresh approach to 3D CAD. It's just a different way of looking at things. So why don't we go and have a look at that? So this is Fusion, or Fusion 360. It's yeah, slightly different look and feel to maybe some of our traditional CAD tools that we have in the portfolio, but standard things apply. So for navigation, how we look around a 3D model, we have standard view cube at the top right here. We're able to manipulate the model, look at it in different orientation, and choose how we view that in a standard way. And then along the top here we have toolbars which are sensitive to what we're doing at any point in time, or context sensitive. We also have what we call a workspace. So depending on what we're actually trying to do, so if I was to go into the render environment, if you like, I could choose to go into that render environment and then obtain a different view of what I've got going on. Okay. Not only that, CAM environment, drawings, so on and so forth, it enables us to switch between those different tool sets within the software and then undertake what we need to do. Moving down a little bit, on the left hand side we have what we call our browser. This lists everything that's in the window effectively. So if I wanted to maybe look at different components or indeed turn them off, so if I just wanted to look at the mechanism of this saw assembly, I could just simply go in and turn those off. Not only that, I can understand how the assembly has been put together. So this is something fairly complex in this case. We'll get into some simpler examples so it's easy to understand what's actually going on in a moment. And then down the bottom we have our timeline. So this is basically a representation of what we've done, the operations that we've undertaken to produce this model. And again, there's quite a lot inside of this. It's a fairly complex assembly, but to give you some idea of how this works, we'll look at that in a moment. So that's loosely termed the design environment. You'll see more of it working in a moment. But when we look at the product itself and how we work with it from an overview point of view, we have what we call the data panel. Okay, and the data panel is our way of looking at the data that we've got available to us. So here I've got listed my projects. You can see I've got a number of projects, including some of the sample files that ship with Fusion 360. And if I go into this folder here, I can actually view the data that Johan's very kindly shared with me. So we've got a PNG file or an image file available. I've got Johan's assembly model here, and I've got a copy of that assembly that I've created here. So I've renamed it to Dave W. Okay, I can open those details on the web. So this is going to our Fusion team portal. What that enables me to do is look at the data from a web portal point of view. So here's the model. If I choose to open that model, I can view it. I can view the different versions. I can start doing additional tasks depending on what it is I want to do. Basically, I'm able to review it. Now I'm doing this through a web browser, as Johan said before. It's device independent, so I can do this on any PC that's basically connected to the web. And that's one of the key things about Fusion 360 is it's cloud-based. Okay, so I work locally. Everything I'm doing from a Fusion point of view as I design is done on my computer, but then when I save the file or shut Fusion down, it automatically saves that back to the web. You can see here I've got a number of different versions available for me. Okay, from here also I can open directly in Fusion. I can download this model if I'm allowed to do so. I can also share as well. So I can invite other people along to collaborate with me. That's where we're looking at that collaborative aspect. I'm also able to mark up and do different things if there's a particular area that I wanted to communicate, and I can save this away, and this will be recorded as a note on this model, so we can actually see that what was actually written, and that's all fully viewable within the in the client, so we can see what's actually going on. Okay. So coming back to our model, I'm just going to open this model up here just to review the part itself. So just to reiterate, this is the file that, as I say, Johan very kindly sent over to us that I've made some modifications to previously. But I'm also going to have a look at some other data that I've got just to get through content really. And rather than looking at pre-prepared data, I'm going to create a new design from scratch and just show you how that works. So in this case, I'm going to design like a cap. This is actually something that I produced for a telescope. I'm into astronomy as well as photography, and I needed a cap for the telescope, so I produced this a little while ago, 3D printed it off. So in the first instance, I'm going to basically start coming up with a concept or an idea. I'm going to use standard tools inside of the CAD world, very easy to understand, and in this case just draw a circle, and I'm going to say that circle is 115 millimeters in diameter. Finish that sketch and then do something with that. So in here I'm now going to produce my first bit of 3D geometry. So as you can see, as I do this, it's very visual, it's very descriptive on what it is I want to do. I can type in numbers, or I can be very free and just drag things around if I'm just dragging or creating early concepts, if you like. In this case, I'm going to produce a disk, and then I'm going to start using some of the other options within the menu. So in this case, simply just choose to create a sketch on that face there, and then add a little bit more detail, just the same as I did before. And this time we're going to choose a different dimension, obviously. And we're going to say we want a wall thickness rather than specifying a particular diameter. So if I zoom in a little bit, you should be able to see what's happening here. I want a wall thickness of say 3 millimeters on this. I'm going to finish that sketch, and then if I just rotate the view round a little bit, I can choose to extrude just this portion just in the same way as before. Again, I'm not going to type in a dimension here, I'm just going to choose to leave it at that. Maybe a rough concept, and that's roughly speaking a rough shape of my cap. From there I'm going to add some more detail to this. So I'm going to add a fillet on. You can see if I move this around a little bit, you should be able to see what's happening. Well, the point here is that it's all visual, it's very easy to understand what's being done. I'm going to choose a 3 mil radius on there, and then I want just a simple chamfer on this top edge, and I will traditionally type in just a value over here. So very quickly and easily I've produced a shape. I can come into here and actually specify what this is made from as well. So in this case I want it made from ABS plastic, and now that I've got that, I would be able to go off and actually see, you know, how much it weighs, things like that, based on that material information and the size of the geometry. So straight away I'm getting real feedback from the design. Okay. So I'm just going to save this as, let's call it demo cap for today. And now I've got that saved. Probably the first thing you want to do with this, depending on what you're doing actually, is create a drawing. So in my case, when I actually did this for real, I didn't need a drawing because I directly 3D printed it. But in this case, just to show you a little bit of the drawings working, we'll choose an A3 border to start with. We'll place this in at a scale of 1:1. Drop that view down, and then from there we're able to very simply project some views around, including an isometric view, which is the typical thing inside of 3D CAD that you don't generally do inside of 2D CAD for any 2D users out there. Depends on what it is, but if it's something complex, then generally it's a time constraint that prevents you from doing that. We can also choose how that's represented as well, so in this case a shaded view, and if we wanted to go into more detail, we could actually do that. So in this case I'm going to very quickly just drop down a sectional view of that as well, so you can see my section view there. Annotations, I'm going to do too much on this just because of time, but just to show you, as we drop those annotations down, we can easily be selective on what we want to annotate, so on and so forth. And I could keep going on obviously and produce a full drawing of that, so I could manufacture it or choose to do that. Things like PDF output, I just drop this on my desktop here, I minimize, just come out of PowerPoint for a moment. Here's my PDF file directly created from the product. But as I say, more and more I'm seeing in industry that people are starting to come away from having to or needing to require that 2D environment. I'm not going to bother saving that. So that's a very brief, and I appreciate it is a very brief on a very simplistic part, just an overview of doing something inside of Fusion 360. I did talk about the timeline before, so the timeline down the bottom, I can go back at any point in time and start looking at that information, understand what I've actually done, so on and so forth. I can modify dimensions if I wanted to. So yeah, maybe if I wanted to get into this feature, I could maybe firm this part of the design up now if I realised that I actually wanted it at 25. Oh, 25, not 258. So again, this timeline just records everything that's done, every operation that you do. Okay, so that's great. That's just a brief overview of something really simple, and to give you a flavour of how the interface works. However, if I wanted to create a new design, but in this case, rather than choosing something prismatic, if I just open this example I've got here of a ring, and this is something I did a few days ago. This is just basically a ring shape, which is based on a physical ring that I actually have from a few years ago. So to design this traditionally in 3D modeling would be quite a chore. Just to give you some idea of how we can approach something like this, we've also got the ability to freeform model. So in this case, I'm going to draw a, let's say, we'll just create a shape for now. Okay, so something like this sort of a shape, a torus. And then from there, first of all, I want to create like kind of an egg cup shape, I guess, or something that we're going to sit a ball in, or something like that. So I want it to be symmetrical. So I've applied some symmetry on here, and then I'm simply going to go in and start clicking on faces or edges, depending on what it is I want to achieve. Just select those three, and then edit that form simply by pushing and pulling. As soon as I start doing this, you can see if I rotate the model around a bit, you can see that I'm free to do whatever it is I need to do, basically. So I can be specific on this. I can rotate those faces. I can start belling this shape out and fleshing my design out to be as organic as I want it to be. I can literally select on any point, any face. I can segment. I can add additional segments, so on and so forth. You should be able to see from there that I've got quite an interesting shape going on, just with a few clicks. Okay. So that's one way of producing more organic shapes very quickly and easily. But obviously being able to create that would be a bit more involved. So in this case, we typically 3D print this. And if I select that for 3D printing and then tell it to go and bring that model in, so I'm now basically within inside of our print studio, within inside of Fusion. And I'm able to position this, or I could tell the software just to drop this down where I need it. Okay, I'm able to look at the layout with a range of tools for if I needed to scale design, measure, lay flat, things like that. If this was imported geometry maybe, so it wasn't typically geometry that I'd created in Fusion, so if there were some problems with it, I could start looking at patching holes and things like that. Because this has come from Fusion, there's no problems with it. And then from a support point of view, I could actually tell the software to go and automatically produce supports, or I can go into manual supports and say, well, if I actually needed a support, maybe not there, but if I needed a support here somewhere, go and drop that support in. If I actually needed it, it's telling me I don't need it. Why it's in red. Okay. The point is that we've got a studio where we can start adding information inside of there, and then when we're finished, we can actually go and produce a representation or the actual data to feed to the 3D printer. So in this case, I've now got the slice information to produce that 3D print, and that's based on the printer that I've chosen, which in this case is the Ultimaker 2. Okay, so you know, more organic design, more concepting, prototyping up front is all available directly inside of Fusion as well. Okay, so just have a quick look and see if there's any questions. Doesn't seem to be, which is good. Okay, we will hopefully have time for questions and answers at the end, maybe five minutes or so. So where to go next? Well, we're going to come back to Johan's example actually, looking at his putter. So this is the modelling environment that I'm inside of at the moment, but if I come into the CAM environment of this part, I'll just let that load up. What I'll see in here is basically this is the full model that Johan's provided to us. So we've got the full information for the putter as it was machined. As you can see here, there's quite a lot involved, as you'd expect really, multiple setups and such like to machine all of that information. But if I just go and look at one of those and go and look at what we've got there, so yeah. If I now play this, it's not going to be that descriptive to you what you're seeing at the moment, because of the way I've got the view set up, but I'll go and explain it and show you how easy it is to do in a moment. But this is basically the tooling information that Johan's created inside of Fusion 360 using the CAM tools, selecting a tool from his tool library and then selecting the profiles of the finished 3D model to actually go and machine. And you can see there that we're simulating that as we go. A really interesting fact that Johan told me earlier this week about particularly this area was that he's got 100% confidence in running through this. He's had no crashes on his machines. He's able to simulate this this tooling path and ensure that everything's fine, and then just let it run on the machine itself. Okay. So I'm not going to let that run through because obviously there's a fair amount of machining in there. But to give you some idea of how easy that is to use, I might just open up this example that I've got that's a bit more simplistic. Okay, so this is something that I've created myself, just as a sample really. And we can see here that we've got some, if I just zoom out a little bit, we've got some basic machining operations. So in this case, if I go and do the same thing here and turn the stock on, so this is basically, the green block is basically our stock material. And if I play that through, you can see that I've got a first operation to face this off. Okay, and then if I move through to simulate this area, we've got the same thing, but because we're only concentrating on one toolpath now, it's actually going to show us the material that's being removed. So I can turn the stock on and off to understand what's going on, or I can just view that as it is. Now that all looks great, and obviously we've got you saw the complicated example that Johan had. But if we let's just delete this. If we just look at that and show you how easy it is to create. So in this case, I'm just going to choose to do not a face, a 2D pocket. So in the first instance, I'm going to select the tool that I want. So this is my tool library. It comes with a standard tool library, and obviously this can be customized. In this case, I'm going to choose a 6mm cutter. The feeds and speeds are automatically in there, but could be overridden and can be customized as you'd expect. And then it's simply a case, in this instance, of just selecting where I want to machine with this operation. And now based on that, I've now got that tooling path. So if I now go and simulate this, you'll see that it's now going to, if I turn on my stock, remember that the stock is only applied for the operation I'm doing, so that the other machining operations are not included in this at the moment. But you can see there, that's how easy it is just to create those pockets. Okay, so that's what we've got inside of the CAM environment. So moving on a little bit, just going to close some of these windows down, and at the moment all we've looked at is basically 2D parts. So I'm going to open a 3D assembly. I know we started with the saw, but I just want to touch on a little bit more of what we've got inside of it. So in this case, we've got a bike frame. So something, there we go. We've got this bike frame here working. So it's a collection of parts. As you can see from our browser, these parts have been designed either on their own and then brought inside of this assembly and assembled together, or they might have even been designed in context of the assembly. so that they reference something else. For what we're doing, I'm not too much interested in the browser at the moment. I just want to show you how we go about things. So in this case, if we now pull this swing arm on the bike frame, you can see that the mechanism's working. But we've obviously got a bit of a problem here because I've not finished constraining things together. So I'm going to add a joint in here and simply choose the type of joint, or we can let the software determine what that is. I'm simply going to fix those two together, so that's where they fix. We get a short animation of what's going on, but in this case that's not that descriptive. If I now move around to that same view and pull the swing arm on the bike, you can now see that the mechanism's working, and probably the last thing we'd want to do is assemble our bolt into there just in the same way. So if we wanted to assemble to our hole there, to our shoulder there, OK that, and now we've got our bolt or cap head actually assigned in there. Okay, so the ability to create parts is obviously important. We need parts to create an assembly, but being able to put that assembly together, understand how it works from a concept point of view maybe. This is a finished design, as you can see, but this could be very simple parts, understanding whether a mechanism works if needed. It's quite easy to do with inside of Fusion. Okay, so with that done, let's just have a look and see if there's any questions. No, all's quiet. Don't know whether that's a good thing or a bad thing. And kind of, well, the two last areas really. So simulation, or being able, now we've got an assembly of parts and we've got some mechanisms going on, we need to understand how that works. Now we could simulate this, this assembly environment. I've got a part that I'm going to look at in this case just to show you what we've got simplistically, if we say. And using our different workspace, so simulation workspace in this instance, and if we open our browser up, we can see here that I've got a design study already done. So this part is a plastic part, and it's a trigger off the saw mechanism or the saw assembly that you saw before. And I want to put some loads and constraints on this to understand what's going to happen when it's actually used. So rather than run what we've already got, I'm going to create one of these from scratch. So you can see here, this is the modules that we've got inside of Fusion as of today. This will be changing in the next few weeks to include more functionality, but for now that's what we've got. I'm going to do a static study. Very simply put, I'm going to consider the material first of all. So I'm going to choose to override the material because it's come from one of my colleagues with a specific material in this case. I'm going to choose this to be ABS plastic. I'm then going to constrain this part to understand where it's or how it's going to work. So in this case we've got some pin constraints on the pins there, and we've also got a constraint here where it sits within the assembly. Okay, and I'm going to apply a load. Now in this case I'm just simply going to apply a load tangential to that face and then put an order of magnitude in there. We'll say, just so we get a result, 100 newtons. Now that we've got that set up, we can run the analysis, but I'm only looking at a simple part in this case. It could quite easily be an assembly as well. We're able to basically run this analysis either on the cloud or locally on my PC for this type of analysis. I'm going to choose locally for now and just let that run. So it's now going to take into account those constraints or pin constraints that I've added on there, and then the load case as well, and it's now giving me a result based on that. So in this case we're looking at safety factor. Based on 100 newtons we're lower than 1, so this is not good. So we'd look at another material or maybe reconsider that 100 newtons that I'm applying on the trigger. Different reports inside of here, so the other typical one is displacement. So we can see it's moving a fair bit. Being able to animate that result as well to understand what's going on. So this is a really good communication tool. In this case, we can actually see, just based on that animation, how this object's flexing. Okay, this is an exaggerated view as well, so it's not actually moving that much. It failed before that probably. Okay, but the point is that we're able to simulate inside of the product. I'm not having to export this information out, do something with it inside of another package, and then run the analysis. It might be that we decide to increase the wall thickness of the plastic part. Because I'm inside of Fusion 360, I can very easily do that if I wanted to, by going back to the model, making a change to the model, and then flicking back to the simulation environment and telling it to update the results or update the analysis. I don't have to do any more in that case. That's one of the benefits of having everything inside of one package. Okay. So, to finish off very quickly is rendering, my favourite part of the environment. And we'll use Johan's example for this. We go to the golf club. So we're going to spin the golf club round, and in this case we're going to arrange the view something like so. You can see we've kind of got a little bit of a studio set up in there. And then I'm able to choose different environments. I'm able to import my own environments if needs be. So if I wanted to place this inside of a crossroads, typically you wouldn't, but just to give an idea, if I did, we could scale that environment, change the size of it if needs be. We could choose how it's orientated, things of that nature. Not the best example, but get the idea. We can zoom that away. Maybe we're going to do a promotional thing with a giant putter in a roadway somewhere nice and sunny. But the point is that we're able to bring those environments just by drag and drop. Okay. We're able to choose how that's actually represented. So if I just wanted a solid colour in here, I'm actually using the lighting information from that environment, and now because I have a solid colour in the background, it looks a little bit more like. I can tweak the camera angle, maybe go for a wider angle lens to make things more pronounced. I can even add some depth of field, so if I wanted this to be in focus here and the rest blurred out, I can do that as well. And then with that done, I can simply render that out. Okay. So we're now rendering that inside of the product. I could choose to render that in the background as well and choose specific size if needed be. The point is that we can get quite a nice image of our design straight inside of the software. Okay. I'm just conscious of time because I'm running out a little bit, so I'm going to quickly flick back to PowerPoint and round off. So just to go back a few slides, just to touch on that rendered environment again, if we come here, so these three images here have been rendered directly out of Fusion. So this was Johan's model with like a wooden plinth that the putter sat on. Really nice, really easy to do. So moving forward then, one of the other key things about Fusion is what's actually in the box and how we're communicating what's coming over time. I wouldn't say in future releases because we're not approaching things in that way. We're basically making the roadmap for Fusion publicly available. So you can go on the website. If you do a Google search for Fusion 360 roadmap, you'll get a more up-to-date view of the information that's on my screen there. So you can actually understand what's currently being worked on, what's planned for the future, and what's actually been delivered. Okay. It's kind of unheard of in the CAD industry, to be quite honest, certainly in my experience of 20 plus years of working with different CAD packages, to actually be that open and transparent on what's happening with the product. Okay, it's a big key area for us. So go and have a look at that by all means, understand what we've got in the pipeline, looking a little bit further ahead. Things are going to change as well with the Fusion 360 product as such, certainly come within the next couple of weeks. We're going to add some more functionality, shall we say, inside of there. That's available on the roadmap website as well. I think, just looking at the feedback, we've got some questions. So as much time as we've got, we're 55 minutes nearly. So we've given a good overview, hopefully, of what Fusion 360 is about. Massive thanks to Johan for joining us today and talking about a little bit about what he's done, and also sharing that information with the golf putter. So it really just remains for me to open that slide up there. If you want to find out more, then autodesk.com/fusion will take you to there, or just do a Google search on Fusion 360 and it'll take you straight to the website. Okay, so questions. This has come in from one person. Okay, so if you're a current user of Inventor, how easy is it to adapt to using Fusion, and why would you choose? Well, it's a fresh approach, but same principles apply. It's not just Inventor, any 3D modeler. Fusion is different, but you know, the ability to create a sketch, draw a profile, that sort of things, it's the same foundation. It's just that things are more intuitive and not traditional CAD, if you like. It's just easier to get on with things. I'd say the key thing is the interface is more intuitive, and the look and feel of how you go about things is more graphical. We've got another one there. Okay, so Fusion as opposed to other options within HSM Express. So yeah, some of the questions, around HSM Express and what's included in Fusion. So there are specifics on those. So I think we've got a table of comparisons somewhere that we could talk through if needs be. So best things with specific questions, I think, is to take those offline and discuss. It really depends on what you're trying to do as to how you'd approach things. Okay. Yeah. So thanks for the great presentation, really helpful. So thanks for the comments there. Standard part libraries, not at the moment as you'd know them in the traditional way, but if you think about your project base, one way to deal with that is to have a project folder or a new project with standard library components inside of there, and drag those into your assembly as required. Okay. So we're almost there time-wise, but that's about it from me. Just really go back to Johan if you're still around, Johan. Anything you'd like to add for the webinar, or what I've covered there?
No, you covered most of it, I think. You mentioned the toolpaths being 100%. I must say I never ever had a difference between the simulation and what code the program puts out to the machine. There's always been reliable. The toolpaths, what you see on the screen is what the machine puts out. So that's awesome. I had some issues with other softwares before. Yeah,
perfect. Thank you. Excellent. Well, thanks again, Johan, for joining us today and sharing the information. And big thank you for everyone that's joined the webinar today. Hopefully it's been really useful for everyone, and if you want to find out more, then go to the website, or by all means drop us an email, and we can answer any questions or put someone in direct contact with you from there. Thank you very much.
Thank you.
Thanks, Johan. Bye.
Bye.